Hello, chemistry students. Today we're going to be performing our spectroscopy of aspirin using volumetric techniques lab. In this laboratory, we're going to learn about visible spectroscopy instrumentation and lab techniques. We're going to analyze a common medicine, and we're going to compare dosage labels with experimentally determined values. Let's get started. The first thing we need to do is mass approximately 0.4 grams of acetyl salicylic acid and add it to a 125 ml Erlenmeyer flask. The mass of our acetyl salicylic acid is 0.4066 grams. We're next going to add 10 milliliters of 1 molar sodium hydroxide solution to our Erlenmeyer flask with the acetyl salicylic acid. And then we're going to heat the flask until the acetyl salicylic acid has dissolved, but we want to make sure not to boil. Okay, so all of our acetyl salicylic acid has dissolved in our sodium hydroxide solution. So we're going to go ahead and turn off the heat on our hot plate, and we're going to use a glass funnel to transfer our solution into a 500 milliliter volumetric flask. And we're going to rinse our flask with deionized water at least 3 times and transfer it into our flask. And then we're going to fill our 500 milliliter volumetric flask to the line with deionized water. Once we have filled our 500 milliliter volumetric flask to the line with deionized water, we're going to stopper our flask and invert to mix at least 10 times. And we're going to label this flask as solution number 1. Next, we're going to use a 5 milliliter pipette to transfer 5.0 milliliters of our solution number 1 to a new 50 ml volumetric flask labeled solution number 2. We're then going to fill our 50 milliliter volumetric flask to the mark using our 0.02 molar iron chloride solution. We're then going to stopper our flask and invert to mix at least 10 times. Your solution 2 should have a purple color. We are next going to prepare our standard solutions for analysis using 5 10 milliliter volumetric flasks. The flasks are labeled A, B, C, D, and E. I'm going to transfer some of our solution 2 to a beaker. We'll then use a pipette to transfer 1 milliliter of our solution 2 into volumetric flask A, 2 milliliters into volumetric flask B, 4 milliliters into volumetric flask C, 6 milliliters into volumetric flask D, and 8 milliliters into volumetric flask E. We will then dilute solution 2 in all of our volumetric flasks to the mark with deionized water. Our standard solutions are now ready to be analyzed on the spectrophotometer in part 4 of our experiment. We now need to prepare 3 aspirin tablets in a similar fashion as we did for the acetylsalicylic acid standard. Our aspirin bottle states that there are 325 milligrams per tablet. We now need to determine the mass of the 3 aspirin tablets that we will be using. The mass of aspirin tablet number 1 is 0.4005 grams. The mass of aspirin tablet number 2 is 0.3899 grams. The mass of aspirin tablet number 3 is 0.3931 grams. We now need to add 10 milliliters of our 1 molar sodium hydroxide solution to each of our 3 Erlenmeyer flasks. And then we will heat our flask with the aspirin tablet and the 1 molar sodium hydroxide solution till we dissolve our aspirin tablet. Okay, so we've allowed our Erlenmeyer flask with our sodium hydroxide solution and the aspirin tablets to boil, and then we've cooled them back down to room temperature. You will notice that there is still some filler and starches remaining in the Erlenmeyer flask. I've also gone ahead and labeled 3 500 ml volumetric flasks as tablet stock solution number 1, number 2, and number 3. We're now going to quantitatively transfer the solution in our Erlenmeyer flask to each of our 500 ml volumetric flasks, and then we're going to fill those 500 ml volumetric flasks to the line with deionized water. We've finished filling our 500 milliliter volumetric flask with deionized water, so we're going to go ahead and stopper each one now. And then we will invert to mix. After thoroughly mixing each of our 500 milliliter volumetric flasks, you need to allow any starches or fillers to settle to the bottom of the volumetric flask. We've allowed the starches and fillers to settle to the bottom of our 500 milliliter volumetric flask. So now we're going to transfer 5 milliliters of each tablet stock solution into a corresponding 50 milliliter volumetric flask. We'll then fill to the line with our 0.02 molar iron chloride solution. After filling our 50 milliliter volumetric flask to the line with our 0.02 molar iron chloride solution, we will now stopper each of the 50 milliliter volumetric flasks and invert to mix. After mixing, our samples are now ready for analysis in the spectrophotometer. I've also gone ahead and made a blank sample, and our blank sample contains everything except for the acetylsalicylic acid. So the blank contains the water, the sodium hydroxide, and the 0.02 molar iron chloride solution. We are now ready for analysis of our samples on the spectrophotometer. We have completed our sample preparation, and I've gone ahead and added 1 milliliter of each of our samples to a cuvette, so our samples are now ready to read on the spectrophotometer. We have our blank, standard solution A, standard solution B, standard solution C, standard solution D, standard solution E, and our aspirin tablet number 1, aspirin tablet number 2, and aspirin tablet number 3. We're now going to set up our spectrophotometer to run our samples. After turning on and allowing our spectrophotometer to initialize, we've inserted our cuvette with our blank sample. We now need to blank our spectrophotometer. In order to do this, we're going to select the Spec200E Modern Interface option. We're going to leave it as live display for our application. Our measurement mode, we're going to change to percent transmittance. And we're going to set our measurement wavelength to 530 nanometers. We will then go down to Go and press Enter. We next need to press the top center button, the 3 zeros, to set the percent transmittance for our blank to 100% transmittance. You can see now that our percent transmittance for our blank is at 100% transmittance. We can now go ahead and analyze the remainder of our samples. The first sample that we'll be analyzing is our standard solution A. The percent transmittance for standard solution A is 94.1%. The next solution we are analyzing is standard solution B. The percent transmittance for standard solution B is 86.1%. The next solution we'll be analyzing is standard solution C. The percent transmittance for standard solution C is 74.5%. The next solution that we will be analyzing is standard solution D. The percent transmittance for standard solution D is 68.2%. The next solution that we will be analyzing is standard solution E. The percent transmittance for standard solution E is 61.2%. The next solution that we will be analyzing is the solution for aspirin tablet number 1. The percent transmittance for aspirin tablet number 1 is 63.4%. The next solution that we'll be analyzing is the solution for aspirin tablet number 2. The percent transmittance for aspirin tablet number 2 is 63.9%. The final solution that we'll be analyzing is the solution for aspirin tablet number 3. The percent transmittance for aspirin tablet number 3 is 63.2%. This concludes the wet lab portion of this experiment. Okay, students, you will now need to convert our percent transmittance readings to absorbance and create a standard curve of absorbance versus concentration. You'll need to use the equation of that line to determine the concentration of the aspirin in our aspirin tablet solutions, and then you'll need to back calculate to determine the amount of aspirin in each tablet. This concludes our spectroscopy of aspirin experiment. Thank you for joining me for this laboratory.